Okay, so when you want to cover the bottom and outside of a can with material, this is very similar to the last video, where we're finding the surface area of something because we're covering the outside and bottom, so we're dealing with surface area. But notice that they're talking about just the bottom and the outside. So we're finding the surface area of this shape down here, which is a cylinder. See, we have the circle on top, this elongated part right here, and a circle on bottom. This is the lateral surface area. That's a cylinder. And the reason we're only finding the surface area of the bottom and outside is because, well, Mary is trying to cover the bottom of a pencil holder. And see these pencils sticking out right here means that there really is no top. So if you want to cover this can with material to make a pencil holder, there's nothing to cover on the top. So what do we do? Well, let's just look at the rest of the information, make sure we're not missing anything here. Okay, so here is this measurement 9 centimeters and this measurement here 4 centimeters. 9 centimeters is the height of the cylinder. And the 4 centimeters is the radius of the cylinder. Because, you know, if you look up here, you see this circle. And 4 centimeters is pointed to the line from the center to the outer part of the circle, which is the radius. And in part A, they want us to calculate the surface area in square centimeters. Again, the square centimeters is referring to how many little square centimeters, 1 by 1 centimeter. This is not drawn to scale, of course. This is my rough picture of a square. Sorry about that. Anyway, it's saying how many squares would it take to cover this cylinder if we were to actually lay them on there and paste them on there with tape or whatever. How many would it take to cover it? So that's something we have to only keep track of when we're writing out the numbers that we're actually referring to as square centimeters. And they actually give us the formula here, which is useful because it's easy to forget, especially when you're taking a test, if you're finding the surface area of this cylinder, that this cylinder has no top, so it has one less side. And that's why we have pi r squared in the first part of the formula. Pi r squared is saying the area of a circle. Usually there would be a 2 pi r squared, but here there's no 2 because there's only one circle in this cylinder. On the bottom, the top is missing. And then we're adding this other formula, 2 pi r h. 2 pi r h is really just the height times this, which is the circumference of the circle. And that's this part right here, which I mentioned before. It's the lateral surface. Excuse me. And I think of it as if you have a circle on the bottom of a cylinder and you move it and you had some kind of like bubble or something, some kind of solution attached to it, you would get this like bubbly hula hoop. And if you solidify that, you would get the lateral surface of a cylinder. But how do we get that? Well, what part of the circle makes this lateral surface? It's the circumference. So the circumference times the height gives us this lateral surface, and that's what this is right here. This part of the formula, 2 pi r, is the circumference, and this part h is the height. So we have all of our information, and they want us to round our answer to the nearest tenth. So what that means is we're going to use pi, and when they don't give you a value of pi to use, and they want you to round to the nearest tenth, we want to use pi as it appears on the calculator. Or have a calculator with a pi button, like right here. Usually using pi to the value of 3.1415 will get you the answer you need to satisfy whatever they're looking for on a test. So let's use the value of pi as it fits on a normal calculator, a standard scientific calculator, and plug it into this equation. So how do we do that? Well, pi r squared, what that really means is the pi multiplied by the radius squared, which is really pi times the radius times the radius. We're going to take that and we're going to add it to this, which means 2 times pi times r times h. And the same thing here, 2 times pi times r times h. So here, I mean, perhaps this looks like a standard calculator, not even scientific, but just a standard small calculator. So if we have 3.14159, 0.535. We'll use that value for pi. So we have this value for pi, and we're going to multiply it by the radius times the radius. So looking back at our problem, our radius is 4. So 4 times 4 is 16, so this is 16 times pi. I'm going to leave it in that format right now. And over here we have 2 times pi times 4 times the height, which is 9. 9 times 4 is 36, times 2 is 72. Now I can write this as 72 times pi, and I can rearrange the order of these numbers when I'm multiplying because of the commutative property of multiplication. And property of multiplication, but I misspelled it, sorry about that. It's the commutative, one more time, the commutative property of multiplication. Now, I even said it before, commutative. I used to say that as a kid. I think that could confuse me. It's the commutative property of multiplication. The keyword being commute. These numbers can commute or move anywhere in any order, and it won't change the answer. So instead of doing 2 times pi, then that times 4 times 9, I can just do 9 times 4, which is 36, times 2, which is 72, and then take that and multiply it by pi, and the answer won't change. Why does that matter? Well, in algebra, if you have, let's say, 16x plus 72x, just like any other example, like simple example 2x plus 4x, this would be 6x. Because you have 2 x's here and 4 x's here, altogether that's 6 x's. What you're doing is adding these two coefficients. So here, 16x plus 72x would just be 88x. Well, we don't have x here, but we do have a constant variable, and that's pi. So 16 pi's plus 72 pi's is 88 pi's. And what is that value as a number? Well, let's go back to our calculator. Here's our calculator. This number times 88. And here we get 276.460153508. So they want us to round to the nearest tenth. This spot right here is the tenths place. So whatever place you're rounding to, is the tens or the hundreds or the thousands, you use the place to the right of it, the smaller place, to figure out what to round the larger place to. So here we have a 6. So we round that 4 up to a 5. So our final answer should be 276.5 square centimeters. Notice how our centimeters to the second power, that's a shortcut for square centimeters. Now, there's another part of this question which says, on the lines below, explain why this formula is used to find the surface area instead of this formula right here. Well, I guess I said that before. If you look, this is 2 pi r squared versus pi r squared, and the reason this pencil case only has a pi r squared instead of 2 pi r squared is because in this surface area there's only one circle, and this pi r squared is the area of one circle. This formula here, 2 pi r squared, that would be true if your pencil case had a circle on top and bottom, but it doesn't.